Potassium dichromate is colored compound. It is reddish orange. But unlike KMNO4, K2Cr2O7 does not act as self-indicator because no dramatic auto color change takes place. So there is no dramatic color, means in case of potassium permanganate, even if the concentration is 10 to the power minus 6 moles per liter of KMNO4, this will result in pink color. So there will be dramatic color change even with very slight concentration. This is not the case for K2Cr2O7 potassium dichromate. So that's why we can't use potassium dichromate as self-indicator. So how do we use potassium dichromate? In these titrations, indicators such as diphenylamine, N-phenylanthranilic acid or potassium ferricyanide are commonly used. And in your syllabus, you don't need to remember any other indicator. Only these three you need to remember. But you have to remember these. In potassium dichromate titrations, indicator is not actually K2Cr2O7, although it is colored reddish orange. Indicator is diphenylamine or N-phenylanthranilic acid or potassium ferricyanide. So what happens here? For example, K2Cr2O7 oxidizes the indicator diphenylamine just after the equivalence point to give intense blue color. In case of potassium permanganate, the color change is from no color to pink color. And that pink color is from the KMNO4 itself. So that's why self-indicator. But in case of K2Cr2O7, it is color changes to intense blue color. And that is due to the oxidation of indicator, that is diphenylamine. Both K2Cr2O7 and KMNO4 are oxidizing agent. Here K2Cr2O7 oxidizes the indicator, which results in intense blue color. How it happens? I'm going to explain that. The chemical equation showing Cr2O7 as an oxidizing agent is this one. This is half reaction indicating how the K2Cr2O7 is acting as oxidizing agent. If it is acting as oxidizing agent, it means it is getting reduced itself. And you can check that with the oxidation number. Here the oxidation number of chromium, if you calculate, if it is X, you will say 2X plus 7 times oxygen minus 2 will be the charge minus 2. So 2x will be 14 minus 2, that is 12, x will be plus 6. So here oxidation state of chromium is plus 6 and here oxidation state of chromium is whatever charge plus 3. So reduction in oxidation state, decrease in oxidation state is reduction. So potassium dichromate is getting reduced. It means it will act as oxidizing agent. Oxidation of ferrous salt with K2Cr2O7 may be written as, so if we write the overall reaction where K2Cr2O7 is acting as oxidizing agent and Fe2 plus will be acting as reducing agent, this is the overall reaction. Now how it happens, how the intense blue color appears, try to understand. In the beaker, suppose you have the ferrous salt and you also add the indicator and say we are using diphenylamine as indicator. And we have already talked about that on oxidation, diphenylamine on oxidation gives us intense blue color. Okay. So what happens initially when you add K2Cr2O7 here? Drop by drop, you're ready. This K2Cr2O7 will react with Fe2 plus ferrous salt. This reaction is faster than reaction of K2Cr2O7 with diphenylamine. So this reaction takes place and K2Cr2O7 is not available for the reaction with diphenylamine. But when entire Fe2 plus ferrous salt is used, there is no ferrous salt, then if you add K2Cr2O7, it will react with diphenylamine, and on oxidation of diphenylamine, we will get intense blue color. So the moment the ferrous salt is used up, you will get blue color on addition of further K2Cr2O7. So because the color changes to intense blue color, that's why we say the end point has been reached.